Good evening and welcome back. For tonight's video, we're going to be discussing the domain and range of quadratic functions. Okay, domain and range of quadratic functions. And before we get into that, let's go ahead and review what domain and range are. Well, the domain refers to all possible x values a function can contain. Okay, all possible x values. So any x I can put into this function and get something out that is in the domain. Okay, and the range is going to be all possible y values. Okay, all possible y values, meaning any y value that comes out is part of my range. Okay, that comes out of that function. So now this is going to be short and sweet, and I have some rough examples, two rough examples drawn up here that we can look and find the domain and range for. As long as we're talking about strict equations like 2x squared minus 4x plus 5 or negative 3x squared plus 5 minus 6x, okay, as long as we're talking just strict equations and not problems, real-world problems or problem situations, you're going to get pretty much cut and dry domain and range. Okay, it's not going to be very difficult. Okay, and 99.9999% of the time, the easiest way to do that is to graph the function. Okay, graph it, have a look at what it looks like, and then try and determine the domain and range from there. Okay, so let's go ahead and get started. Domain is what we're going to get started with here. I want to find the domain of this guy. Now again, domain is all possible x values. And I always like starting at the left. You know, we read from left to right. So let's start on the left-hand side of this graph. So as I move to the left on the x-axis, I can see that this line is moving down and to the left the whole way, okay? And it's going to keep going. Now, this arrow means that the line continues on forever and ever and ever, right? As that equation, that function does. Okay, so I want to ask myself, as I'm moving left here, how far left is this line going to go? And this arrow indicates the fact that it's still slightly tilted, it's not a vertical line. The arrow indicates that it's going to go all the way to negative infinity. Okay, negative infinity. And then I'm going to ask myself the same question, except moving to my positives, going towards the right-hand side. Okay, how far is this arrow going to travel to the right? And as you can see, it's sweeping down, but it's not vertical. It's still traveling to the right. It's still slightly slanted there, which means it's going to keep going to the right forever and ever and ever. Okay, so that's going to be to positive infinity. Okay, now a more specific way to denote this, way you may also see it, is negative infinity is less than x is less than positive infinity. And probably an even more common way to denote this is just going to be x is an element of all real numbers. Okay, x is an element of all real numbers. Now, range is where it's going to get a little different here. Okay, range is where it's going to get a little different. Range is going to be the same kind of thing as domain, except this time I'm dealing with the y-axis here. I'm dealing with the y values. So I'm going to start again at the negative. So as I move down my y-axis, I want to ask myself, how far are these lines going to travel downward? And the truth is that they're going to travel downward forever. Okay, they're never going to stop. All right, so my range is going to start with a negative infinity. And I'm going to ask, what does it go to? So then we need to ask ourselves, if I travel upward here, if I'm moving up, what's the highest number I'm going to get here? And, well, that's real simple because the graph doesn't actually extend up here, okay? It stops moving upward at this point, and that's going to be the point 4. Okay, that's going to be the y value 4. So my range actually only goes from negative infinity to positive 4. And again, a more mathy way to denote this is going to be negative infinity is less than y, because this is range, is less than or equal to 4. And that's going to be my range for this function. Now that we've taken a look at a quadratic curve or a parabola that's open downward like an N, let's take a look at one that's open upward like a U. Okay, so let's take a look at this guy right here, okay, this parabola, and let's determine the domain. So looking at this, I'm going to ask myself the same question I asked last time, and that is, starting moving to the left in my negatives, how far is this function going to go to the left? And as you can see, this arrow, this line here, is traveling slightly to the left. So the domain's going to start with a negative infinity because it's going to keep going that way forever. Okay, it'll keep curving slowly upward, but it's still moving, even if it's like 0.01 movement to the left. It's still moving to the left, so it's going to be a negative infinity. And the same question for the positive x-axis. As I move to the right, how far to the right is this line going to move? And again, we're going to run into a positive infinity situation. So my domain is going to be negative infinity to positive infinity. And we can go through the writing it in preferable math speak here. The negative x is less than, negative infinity is less than x, which is less than infinity, or x is an element of all real numbers. Okay. So if you're looking on how you're probably going to see this most often, it's going to be one of these two ways here. Okay. And last but not least, range. Now, as you can see, our range isn't going to be negative infinity to positive infinity because part of this graph, part of this coordinate plane isn't touched at all by this graph. So let's start like we always do. What's the smallest number? As I move down, how far down is this graph going to go? Okay, how far down? And we can see that it doesn't extend past negative 6. Okay, everything else is above that. So my lowest number here is going to be negative 6. And then I want to ask, how far up is it going to go? Okay, how far is this thing going to move upwards? And with these arrows here on the end of that graph, you can see that it's going to go up forever and ever and ever, or to positive infinity. Okay, and again, we can denote that as negative 6 is less than or equal to y is less than or equal to positive infinity. So you can see from these two examples that as long as you don't have a real-world situation where you have to, the domain and range aren't restricted, meaning we cut it off at negative numbers or something like that. As long as you don't have that kind of situation, for every quadratic equation, the domain is going to be negative infinity to positive infinity. Okay? And the range is going to be limited at some positive or negative value. Okay, you're never going to have a quadratic function that has a range of negative infinity to positive infinity. That's not possible. Okay, the range is always going to be limited at some number. One side being infinity, like here, the right side, or up here, the left side, and one side being a finite value. All right, thank you very much and have a good night.